Hi everyone. Today I'm going to be showing you guys how to fill up a proforma for a compass error calculation that uses a star as a celestial body. So in my other video you must have seen the use of proforma for a compass error calculation for sun as a celestial body, and this proforma for star is slightly different from the one that we used for sun. So I thought I will make a video on this topic as well. Alright, so this is what a proforma looks like. We will be using an example, a question, and using that example I'll show you how you can fill up the proforma when it's required. Alright, so let's get started. So in today's question we have a star as a celestial body, and we'll be using the proforma for calculating the compass error using the azimuth method. So we have two methods of calculating compass error. We have amplitude and azimuth method. So today we'll be using the azimuth method, and of course like I said before, we'll be using star as an example of a celestial body. So what is the question? The question is, during the evening of December 19 at approximately 20:31 zone time. Zone time is same as ship's time, the time that you keep on your ship's clock. GMT was minus 3 hours. What does GMT minus 3 hours means? It means that GMT was 3 hours ahead of the local time, or your local time. You were 3 hours behind GMT. GMT minus 3 hours was the local time on your ship. You are in position 61 degrees 13 minutes north and 052 degrees 19 minutes west. The star was Azimuth. Azimuth is the name of the star that had a compass bearing of 330 degrees. 330 degrees compass bearing. And a chronometer which was correct on GMT showing 11:31:15. Alright. You have to find the deviation of the compass. That is the purpose, and of course for that you will have to find the compass error if the variation given to you was 40 degrees east. Alright, so this is the question. So make sure that you have noted down the hint. One of the hints is that it is evening on your ship, it is December 19th on your ship, and it is 20:31 on the ship's clock. Alright, and the star is Azimuth. So using these details, we'll go to the proforma now and start filling up the proforma, or the details of the proforma. So what I'll do is I'll go into the proforma here, and here we have the proforma that I can start filling up. So let me just start filling up the proforma here. Alright, so what is given to us is our chronometer time, which is 11:31:15. So that's the first thing we can do, is fill up 11:31:15. I will not fill up the date now. I'll tell you later why I will not fill up the date. And then we have the chronometer error, which doesn't exist. So chronometer is correct on the GMT, so the chronometer error doesn't exist. So our GMT time is 11:31:15. Now how would I know that this is the correct GMT time, and what is the date of it? Now for that I have to use the hint given to me in the question, that it is 19th of December, but it is 20:31 on my ship's clock, and I am on my ship, I'm 3 hours behind GMT. So if I'm 3 hours behind GMT, so UT or GMT, it's pretty much the same thing. There's a small difference, but we'll not get into it now. So UT and GMT for today's question is the same thing. So if we have a GMT of 11:31 and 15, and I'm 3 hours behind GMT, so the zone correction is minus 3 hours, as is given in the question as well. And this zone correction, as you all know, we get it from the longitude, but it's a round number. So the ship's time, or the zone time on my ship, or the ship's mean time, should be 8:31:15. So this should be the time on the ship's clock based on my GMT time. But the question says that the GMT time given to me, the GMT time given is 20:31 hours. So that means this GMT time, or rather not the GMT time given, I'm sorry, but it's the zone time that is given to me, not the GMT time, I'm sorry. The zone time that is given to me in the ships in the question is 20:31. It says it's evening on my ship and it's 20:31. So this GMT time that I have calculated cannot be correct. So what do I do? So what I will do is I will take this chronometer time and I will add 12 hours to it. Alright, so if I add 12 hours, what does this become? 11 plus 12 is 23. Right, so what will 11 plus 12 becomes 23 hours. And then I'll get rid of this. So I have added 12 hours to it, and what I have done is 23, there is no error, so my GMT time now is 23:31:15. I still don't have the date. Now why I have added 12 hours to it? Because when the chronometer is showing me 11:31:15, it could be 11 in the morning or 11 at night. Now if it's 11 in the morning, my answer didn't work out. So if it's 11 at night at GMT, let me see if my answer works out or not. Alright, so if I say my GMT is 23:31, the date is still not known to me. I'll work it out. And I'm 3 hours behind GMT. My zone is 3 hours behind GMT. So what is the zone time I get is 20:31:15. Now does this match with the hint given to me in the question? Yes, it does. Because the question says the zone time on my ship is 20:31. And here also the zone time is 20:31 if my GMT is 23:31:15. Right? And the date given to me in the question is 19th of December. That means if I am 3 hours behind GMT, the GMT is also 19th of December. Right? So now I can put here date 19th of December. Alright? Got it? So this is how I work out my GMT time. Now the zone time is purely there for a hint purpose, only for me to work out the GMT time. I don't have to use my zone time for any other purpose. So if I want, I can get rid of it or I can cross it. Because I'm working with an electronic document, I can just erase it. But if you're working on paper, just put a cross on it, because you have to work with the GMT time now for the rest of the question. Now we'll be using 19 December 23:31:15 and going into the nautical almanac. So if I go to the nautical almanac, I'll be getting a few values from there and I'll show you what values I get from there. Right? So I'll go into the nautical almanac for December 19th. As you can see, this is December 19th here. And I can focus here. This is December 19, 2004. So the almanac, the year of the almanac doesn't matter here. You are learning the procedure of filling up the proforma. So if you don't have 2004 nautical almanac, don't stress about it. Right? You can get the values from here. So what are the values I can get from here? So let me show you what values I can get from here. So firstly, this is 19th of December here. Right? And I'll be going under the column of Aries because I'm working with stars. So all stars come under the column of Aries. This is where the GHA is given. So GHA star for, GHA Aries for 19 December and GMT time 2000 hours is 28:45 degree for 28. So my GMT time is, my GMT time is not 20. My GMT time is 23, not 20. Right. So my GMT time is 23 hours and my GHA Aries is 73:52.5. Right, so I can just highlight it here for you. 23 hours. So remember, I have to use my GMT time, not use my zone time. 2300 hours is my GMT time, so I've got my GHA Aries from there. And then what else can I get from here? I can get the star. You see the star is here, Elliot. The star is here, Elliot is here, so I can get my SHA, which is 166.26.4. I can get my declination, which is 55 degrees 55.7 minutes north. So I'm getting all these values straight off right now because I don't want to go back and forth between the nautical almanac and the proforma. If I can show you where these values are, then I can just go into the proforma now and start filling up these values. Right, the last thing I have to get from the proforma is the increment. So how do I get the increment? The increment is for the minutes and the seconds. So the minutes and the second is 31 and 15. So I'll go into the increments page at the back of the almanac. You can see 31 is right here. So 31 minutes is here, 15 seconds is here, and I'll be going under the Aries column. So that is gives me an increment of 7 degree and 50 minutes. 7 degree and 50 minutes is my increment. So now I have got all the values I need. I've got the GHA Aries, I've got SHA star, I've got declination of star, I've got increment as well. I can now go into the almanac, or rather the proforma, and start filling up the proforma as required by the values I have got. So let me start with GHA Aries here. My GHA Aries was 73 degrees 52.5, right? My increment, which is always added to GHA, was 7 degrees and 50 minutes. So if I add these two together, I will get a GHA Aries of 81 degrees 42.5 minutes, right? Then SHA star, SHA is also always added to GHA. My SHA star was 166 degrees 26.4 minutes. SHA is always added to GHA and it will give me GHA star. So GHA Aries plus SHA star gives me GHA star, which is 248 degrees 08.9 minutes. Now remember, if you are adding increment and SHA to GHA, and if your GHA star, if it becomes more than 360, then subtract 360 from it. Alright, so in this case it is less than 360, that's fine. If this value was more than 360, then you will subtract 360 from it. Right, so if it was 400, you will subtract 360, it would have become 40 degrees. So GHA star can never be more than 360. Now we take our longitude and apply our longitude. So longitude west, this is longitude west. GHA is the best. That means GHA should be more than LHA. So longitude west, GHA is the best. It should be more than LHA. If longitude was east, GHA would have been least. It would have been less than LHA. So here my LHA is 195 degrees 49.9 minutes after I subtract my longitude from the GHA. Alright, once I have done that, I have to name my LHA now. Now LHA is named according to this rule. If it's 0 to 180, it's west. If it's more than 180 to 360, it's east. So LHA is east here. We name it east. I'll tell you the relevance of it as we go down and we have to name our azimuth. We will use this information. So we will name the LHA east. Then once you have got your LHA, you can start filling the rest. So here also you can write down the latitude if you want to write down the latitude. The latitude given to you is 6113. So if you want, you can write down these values as well. 6113 north and 052 degrees 90 minutes west. Alright, let's get started with the rest. So the declination now. The declination was 55 degrees 55.7 minutes north, which we got from the almanac. So fantastic. We written the declination as well. Now we'll be calculating A. What is A? A is equal to tan lat divided by tan of LHA. So tan of latitude divided by tan of LHA. And you will name it opposite to the latitude except when your LHA is between 90 and 270. Now here your LHA is between 90 and 270. 195 degrees lies between 90 and 270. So you will not name it opposite to latitude, you will name it same as latitude. So your A has to be named same as latitude, north. Alright, so now you put in your calculators tan lat divided by tan of LHA and see what you get. So tan of latitude divided by tan of LHA, and you should be getting somewhere around 6.42. If you are getting any negative sign, ignore the negative sign. Alright, ignore negative signs in your calculator. Just put the value and name it. Name it according to the rule that I've explained. So you name A opposite to latitude unless your LHA is between 90 and 270. Now here, because the LHA is between 90 and 270, you will name it same as latitude. Similarly, now you calculate B. B is nothing but tan of declination divided by sine of LHA. So in your calculator, put tan declination divided by sine of LHA. What you will be getting is 5.42, and the rule for naming B is it's named same as declination. So your declination is north, you will name it north. And again, if you are getting any negative values in the calculator, ignore the negative sign. We never include negative signs in A or B. Alright. Now C. How do we get C? C is if they are A and B is same names, you will add them. If they are different names, you will subtract them. So here A and B is same names. Both are north. So you will add them. Right. So if you add them, you get 11.84 north. If one was north, the other was south, you would have subtracted one from the other and named it according to the larger value. Alright, Finally, calculate tan of azimuth by this formula here. Tan of azimuth equals 1 divided by c times cos of latitude. Now don't forget that c times cos of latitude here is in brackets, it's in parenthesis. In your calculator, do not put 1 divided by c times cos of lat. You have to include the bracket, you have to include the parenthesis, otherwise you will get the wrong value. Alright, so 1 divided by bracket c times cos lat, bracket closed, and you will get the tan azimuth. Alright, tan azimuth, and then azimuth equals tan inverse of the value. The answer that you should be getting should be somewhere close to 9.9. Right, so 1, I'll just work it out with you. 1 divided by bracket open c. What is c? C is 11.84 multiplied by cos of latitude, cos of your latitude, 61 degrees 13 minutes. Right, is 0.175409. Shift tan inverse, and you should be getting 9.94 or 9.95. Just keep 9.9, that's enough. Now how do you name the azimuth? Azimuth is name of C and LHA. So name of C, C is north, you will name it north, and LHA is east. Remember I told you we'll use this information. LHA is east, you will name it east. Now north 9.9 east is same as 9.9, right? Because northeast is going 9.9 east from north. North is 000 degrees, east is 090 degrees. So if you are going 9.9 degrees from 000, it's still 9.9. So you will limit 9.9. So your true bearing is also 009.9. It's the same. What is your compass bearing? Your compass bearing is 330 degrees given to you in the question. The question says is 330 degrees compass. So difference between true and compass will give you the compass error. So here what is the difference? The difference is 39.9 degrees. Now why is it 39.9? Because if your compass bearing is somewhere here and this is 330, what's the difference? I'll change the color of the pen. You can see this is 30 degrees plus 9.9, 39.9 degrees. And because compass is less or more here, so compass is less than true. True is ahead of compass. So therefore your error will be east. Compass least, error east. Now you might say, why is compass lesser? Because compass is more than, compass is the value of the compass bearing is 330. Whereas the bearing, true bearing is 9.9. Now 330 is greater than 9.9. No, you cannot make a comparison like that. If you are subtracting, if you are finding out the difference between 9.9 and 330, it's basically 9.9 is nothing but if you are subtracting it, this 9.9 becomes 360 plus 9.9. That's why it's actually you are comparing 369.9 with 330. That's why true bearing is more and compass is less. Compass least, error east. That is why. Alright, so 9.9 of course is the true bearing, but when we are comparing these two, we cannot compare 9.9 to 330. We have to make it a larger number by adding 360. So that becomes a larger number. Alright, otherwise the error would be somewhere in 321 degrees east. That is not possible. Alright, so you don't compare it like that. So that is where your error is east because your compass is least. Then the variation given to you is 40 degrees east. It's given to you in the question. Variation and deviation together form your error. So here of course your error will be 0.1 degree west. The difference between variation and deviation will give you the compass error. Alright, so this is how you get your deviation. Now variation is 40 degrees east means, if I have to explain it to you, that means your magnetic is somewhere here, your magnetic bearing somewhere here. This is your magnetic bearing. Variation is east means magnetic is least. So you are about 0.1 degree more here. So that is where your magnetic is. This is your true bearing. This is your compass bearing. Right? This is your true bearing. This is your magnetic bearing. So therefore deviation is the difference between magnetic bearing and compass bearing. So therefore, and because magnetic is or compass is to the west of magnetic, therefore your deviation is 0.1 degree west. Although it's almost and the same line. I'm just trying to show the difference here. Alright, so I have made videos on compass error calculation and explained deviation, variation and compass error in other videos as well, so I won't go into the depths of it. Here this video was purely to explain how to use the proforma or how to fill up the proforma so that you can use these proformas for celestial navigation calculation, and it makes your job easier. You don't have to remember a lot of the formulas. All you have to do is basically fill values and use the proformas as provided, use the formulas as suggested. Alright, if you have any concerns, queries, feedback, I look forward to it. Thank you for watching this video and thank you for support.